So, good morning, everyone, and welcome to Amazon CodeCatalyst Dev Environments in Action. I'm Tamir Karia. I'm Product Manager with AWS IDEs and Tools team. I work across a bunch of solutions that you might be familiar with. So, we cover AWS Cloud 9, which is a browser-based IDE. We also own AWS Cloud Shell, an on-demand terminal in the AWS Management Console. We have the IDE toolkits, which are a set of extensions for your IDE that help you work with AWS resources. And today, as of this morning, we have development environments, dev environments, as we're calling them. So I wanted to broadly split this talk into two pieces. So in case you missed this morning, we launched CodeCatalyst, an integrated dev environment, which is I think, a wonderful and big release for us. So I'm going to break this talk into two pieces. I'm going to give you a little overview of CodeCatalyst as a whole. And then I'm going to pass it over to my colleague, Rahul, and he's going to walk you through a little closer how dev environments work, what the benefits are, show a few demos, and show you how to use them from various IDEs. So that's the plan. And before we get started, I kind of want to get a feel for who you all are. So how many folks here consider themselves sort of developers, spending hours a day coding? That's great. And how many people are more on the sort of SRE, infrastructure, ops side of things? Cool. And then lastly, how many of you are familiar with any of our code products? So code build, code deploy, code pipeline, and you've used those. Terrific. So this will be great. Thank you. So I'm going to walk you through quickly the agenda here. So like I said, a brief tour of CodeCatalyst, why we built it, some of the challenges facing developers that we hear about these days. I want to look at what is a dev environment, what does it do for you, why do we think it's interesting, how does it work. Rahul's going to touch on all those pieces, including a demo of using dev environments with the default IDE that happens in the CodeCatalyst website, which is Cloud 9. And then we're going to look at the options available for dev environments in terms of compute sizing and storage and all the choices you can make. Then we're going to do a few more demos, and then we'll wrap it up with how to get started. So I want to take you on a sort of tour of history here a little bit. And as many of you seem to know, we have a set of dev tools already in Amazon, in AWS. And these go from left to right on this slide. The code authoring experience, which is Cloud 9, the IDE toolkits, if you have those installed in your IDE, the SDKs, all the way towards deployment, right? So through code commit, code artifact, code build, code deploy. And then we orchestrate that whole layer with AWS Code Pipeline. And, we've shipped these services historically as individual building blocks. So this gives you an almost infinite variety of secure development and deployment workflows and a tremendous amount of scalability. But sometimes, as we've heard from you folks and others, scalability, flexibility, not scalability, but flexibility brings challenges, right? So you don't know whether to go, how to integrate something with something else, which product you should use. There's a lot of choice that you have to make and a lot of decisions you need to make up front before getting started even on a project. So what are those decisions and what are the challenges? The first one is setting up projects and integrating tools. So like we said, you can bring your own tools. We allow you sort of an endless mix and match to integrate with our tools. You might choose to use any of the code tools that we have individually. You might choose to use them together. You might choose to integrate them with your existing workflows somehow. But this is a very specific type of build that needs to happen. Customers tell us they love the flexibility and all the possibilities that are enabled by the code tools individually, but we're starting to understand, or we hear you, that you want to spend time delivering value to your customers instead of configuring build tools and doing these things. So we need to sort of think about another approach to this. Second issue that we see, automating CI/CD and development environments. So, if you've ever worked on a fairly large-scale software project, you know that the CI/CD setup can be, I want to use a different word, let's call it challenging to get right. So, you need to provision the right infrastructure, create pipelines, create tests, and ensure that changes are flowing through those pipelines correctly. You might even have multiple stages, alpha, beta, integ, gamma, prod, and all of those pipelines and stages need to be managed. It's a lot, and it's great for a certain type of enterprise and a certain type of business, not perfect for everybody. And we needed to sort of take an approach that just works. The third issue that we hear from you is, you gave us this promise of cloud development, and it just seems that things have gotten more complex. It's harder to develop now. And that's a consequence of multiple tools, multiple frameworks. You're working on projects in different languages across different infrastructure. It does get complex quickly. You're switching between working on front-end code, back-end code, other pieces of your system, and doing that takes time right now on your local machine. And spoiler alert, you're going to hear our solution to this when Rahul gets on the stage. So with these changes in mind, with these challenges in mind, we knew we needed to go back to the drawing board and rethink how we're building and shipping and developing software from scratch. And this is kind of the genesis of CodeCatalyst. So what is CodeCatalyst? CodeCatalyst is a package of all the tools that you need to build and deploy software so you can move quickly from an idea to an experiment to production. So we put all these tools to plan, author, build, test, deploy applications in one box. So instead of having this linear process, you have this more federated architecture. So full disclosure, I don't want to steal any thunder from my colleagues who are presenting CodeCatalyst in its entirety later on, and we want to focus on dev environments today. But if you can, I would encourage you to join DOP317 and DOP317 later on if you want a deeper dive on CodeCatalyst as a whole. So that said, I will talk about just a few of the key features of CodeCatalyst that I think are super interesting. So we have this thing called blueprints. If you're starting a new project, normally blueprints are scaffolded code that get you started quickly with just the code side of it. CodeCatalyst blueprints give you a CI/CD workflow, a testing infrastructure, source code available in multiple languages and for multiple front-end frameworks. It makes it really easy to get started incredibly quickly, get to your first build, get to your first deployment, and get software out into the world. And we've been playing with this for the last however many months. It really does just work out of the box. So I encourage you to give the blueprints a shot. Of course, you can also come with an empty project, import your existing code, and you still get the benefit of tools that all work together seamlessly. CodeCatalyst also includes integrated issue tracking, which is actually quite nicely done. It's done with Kanban boards, if you're familiar with those. And we also have the ability to very, very simply invite your colleagues and teammates into your space. And the space is sort of the top level container in CodeCatalyst for your projects. So you can do that just by sending an email. So you enter in the email of the person that you want to invite, boom, they get an email, they click on it, brings them right into the space, and they're ready to go, they're ready to code. And so I also want to talk about one thing that's not on this slide, but it is my second favorite feature of CodeCatalyst, which is the very powerful search tool that they have. So I found myself using this all the time. You can search across all your projects, source code, spaces, every asset that you have in your CodeCatalyst space. Search works brilliantly. So, and of course, then begs the question, what's my favorite feature of CodeCatalyst? Well, that would then be development environments. And development environments are built to save you time reconfiguring your laptop locally every time you change working on a different project or a different task. The other benefit is because you have these standardized development environments, you can share them across your team. And effectively, that ends it works on my machine problems, which I think we're all familiar with. So, we have two benefits then. We have sort of the individual benefit to you of not struggling to reconfigure everything, and across your team, once it's set up once, everybody benefits. So that said, I want to summarize where we are with CodeCatalyst. You can spend less of your time stitching tools together, making decisions that might be premature for you, and you can always reconsider those later on. So you don't need to be working with pipelines and tooling, and you can spend time shipping value to your customers. CodeCatalyst gives you this one-stop shop for CI/CD, issue tracking, testing, and of course, development environments. So now, I'm going to pass it over to Rahul. He's going to give you a walkthrough on development environments and go into a little depth on how to use them from the IDEs. And once again, if you check out DOP317 or 208, there'll be more talk about CodeCatalyst. So Rahul, over to you.
Thank you, Timur. Hey, everyone. So just to recap, CodeCatalyst is one place, one location for all your software development needs. Now, let's turn our attention to CodeCatalyst dev environments. In case you missed it, my name is Rahul. I work alongside Timur. I'm a PM on the AWS IDEs team. Today, there are a couple of recurring problems that kill developer productivity. Before you begin contributing to a project, you have to set up your machine, you have to clone the source code locally, install the right libraries, packages, and dependencies. Even after doing so, you have to stay up to date with the latest packages. More often than not, this leads to a configuration drift of your development environments. And at this point, do you know what's the most frustrating thing to hear? It works on my machine. Now, before we dive deeper into dev environments, let's talk a bit about IDEs, the primary productivity and creativity tool for software developers. So far, we have been running IDEs on our laptops, meaning that IDEs use local compute and storage. This means the performance and configurations are restricted by the hardware specs of our laptops. Even as applications move to the cloud and software becomes a mix of languages and frameworks, developers still primarily work on local machines, which tend to be underpowered for compute-intensive tasks. What developers tell us is that this effort to get set up has too much overhead, is error-prone, and demands daily maintenance. Developers can't easily switch between projects without investing a lot of time getting the configuration of their local machine right. What if we could split IDEs into two components for a better remote development experience? The first component, where the keystrokes are entered, the UI of your IDE, also known as thin client, running locally on your laptop. The second component, where the keystrokes are processed and software is built and tested. With dev environments, we split the IDE from the environment and move the environment to the AWS cloud. So why do we need dev environments? Let's look at a few reasons. Now, a lot of time and productivity is lost because what works flawlessly on my machine returns all kinds of errors and warnings on Timir's machine. Each project comes with its own set of dependencies. For example, my Flask web app needs Python 3.1, while my TensorFlow tutorial requires Python 3.7. And then I run into all kinds of version conflicts, which can be extremely frustrating. Because dev environments contain all the required packages, dependencies, and libraries, they are ready to code. Whenever there are IDE updates, we worry about the backward compatibility issues before upgrades. What if you could pick the latest stable version of an IDE, clone your project to it, test it out, and to see if it's a good fit for your projects? What if you're no longer constrained by the hardware specs of your laptop? So instead of upgrading to a new laptop, you could provision dev environments that are suitable for the task at hand. Lastly, what if you could give your team a common view of the world by creating repeatable dev environments from scratch, from blueprints, or from a Git repository? Fully integrated with your source code, projects, blueprints available on CodeCatalyst, and we make it easy to deploy your apps to the AWS cloud. What's a dev environment? Internally, we think of dev environments as Git branches for your laptop, meaning we create them as we need them and dispose them when a task is complete. Dev environments are fully managed and cloud-based. You can create them when you want them. You can dispose them when you're done. They can be provisioned with a single click, and they can be launched in seconds. You can also configure your project repository, select or create new branches. Dev environments are supported with Dev File Standard, which is an open standard that allows you to define dev environments as code. Dev files ensure that you have consistently configured environments, version controlled in your project repo, and for CodeCatalyst dev environments, we use a default universal file, or you can create or customize your own dev files. Dev environments are also resizable as needed. You can use various CPU, memory, and storage configurations to match your development needs. They can be created directly from within CodeCatalyst website or your favorite IDEs, which includes JetBrains and VS Code. Now let's look at a few demos. Now, because I love cheesecakes, I have created a cheesecake shop. As you can see, this is the CodeCatalyst console with my project and my blueprint configured in it. Just to give you some context, Cheesecake Shop is the space in here. Space is what represents your team. New York Cheesecake is a project blueprint. Now I'm going to create a new project. As you can see, there are a wide selection of blueprints available. These are curated by AWS, and you can pick and choose your favorite blueprint to get going. These are great for educational and experimental purposes. I'm going to select single-page application and give it a name. It takes a few seconds for the application to be created. By the way, this is all actual. There's no time warp in here, so this is how it actually took for me to create that project. OK, I see a repository has been created. I have a README file. I'm going to view the repository and look at the directory structure. Blueprints come with a dev file, which is the default dev file that we provide. You can customize it or edit it as to suit your needs. I'm going to edit this particular dev file. And the reason why I'm doing so, because for my project, I need NPM. So I'm going to edit it and install the NPM. So I have a ready-to-code copy-pasted command. Let's have a look at it. It's a dev file command. The command line says which command will be executed. It specifies the working directory, projects/spa app, which is the single page app. And I also specify the event, in which case this is post-start. So once the dev environment is created, at that point in time, I would like this to be executed. So I'm going to copy paste it. And commit the changes. Okay, once the change has been committed, I'll navigate to the dev environments menu item. When you create a dev environment, you see a wide selection of IDEs. This includes AWS Cloud9, which is our browser-based IDE. You also get to see Visual Studio Code. And we support 3 JetBrains IDEs today, which includes IntelliJ IDEA Ultimate, Golang, and PyCharm Professional. For the purposes of this demo, I'm going to select Cloud9. I'm going to clone an existing repository, which is single-page app, select the main branch, and give it a name. Now, further down, you can see dev environments can be configured with different compute and storage options. I'm going to hit Edit and select the large machine size. So what is happening in the background is that we are provisioning a Cloud9 instance with all your packages and project repository correctly configured so that it's ready to code the moment it loads up. There you go. So Cloud9 comes with a terminal. Let's look at the terminal at the bottom of the screen. I see in my projects directory, the single page app exists. I'm going to ignore this dialog box for now. Navigate to SPA app, and I see my node modules are available. So basically, this means that you can install packages, dependencies by configuring your dev files. Let's look at the dev file, which is hosted in here. And you could see that at the bottom, the npm command is available. OK, now let's look at JetBrains Gateway. For those of you who are unaware, JetBrains Gateway is a compact desktop app that allows you to create remote development environments using JetBrains IDEs, and you can connect to various service providers such as CodeCatalyst dev environments. Now, as you can see here, I have JetBrains Gateway available on my Mac. I'm going to load it and navigate to CodeCatalyst. At this point in time, I've already logged into my CodeCatalyst account, so we assume we start our journey from here. Now you can see my Cheesecake shop space is loaded on the top. I can see the project. And now I'm going to create a dev environment from JetBrains Gateway. As you can see, there are 3 latest stable builds available for various JetBrains IDEs. Since this is a Flask-based app, I'm going to use PyCharm for my demo. I select PyCharm, stick to the main branch, again, give it an alias. And you can see those familiar compute and storage options are available here as well. And at this point, dev environment is being provisioned with all the dependencies installed for your project, and it's going to be a PyCharm front-end app. I'm going to, in the interest of time, I'm going to skip forward. All right, so this is the PyCharm interface. As you can see, my repository is available here on the left side. And as you can see at the bottom, the code is being indexed, and various IDE operations are now being performed. There is an app.py. I'm going to flip it open. And the reason why I'm in here, because the Cheesecake Shop website that I have, they may notice that there is something off on that website. So he messaged me, and that's what I'm going to look at, what is wrong on that website and how I can fix it. So as you can see, it's rendering a simple index.html. I'm going to run app.py. The cool thing about PyCharm is that you can do port forwarding. So even though your environment is running in the cloud, you can test your changes locally, just the way you would develop a web app locally on your machine. You can go to localhost and see the changes. I'm going to select port forwarding, open it in the browser, and the website is here. I notice that there is a typo. And now I know what needs to be fixed. So now I navigate back to index.html, find the problematic piece of my code, make the change, and I'm going to rerun Flask. I go back to the browser, do a refresh, and as you can see, the change has been deployed. Once I feel good about the change, I'm going to do git commit and push, and all the changes will be uploaded to the right repository. Now, there are various options available for dev environments. You can start with an empty repository. You can start from a blueprint, or you can create an empty dev environment. You can also choose from various machine sizes, small, medium, large, or X-large. In this case, it's 2 cores, 4 cores, 8, and 16 cores. You also have persistent storage configurations, which are available in 16, 32, and 64 gigs. You can also configure timeouts to save costs. These timeouts can be configured for up to 8 hours, and they start from 15 minutes. Now let's see what we have in store for our VS Code customers. Now my colleague Mike told me about an open source repository that he created on GitHub, and he asked me to check it out. I'm going to navigate to his GitHub repo and see what is it about. So what we have in here is a repository with implementations and details around various types and programming languages. And I see a README in here, which we will make use of later on. For the purposes of this demo, I cloned this GitHub repository into CodeCatalyst. And you can see the clone was done in here. It's the same file structure. Now I'm going to spin up VS Code. For those of you who may be unaware, AWS has an open source plugin called AWS Toolkit, which allows you to interact with AWS right from VS Code and other IDEs. I navigate to the left-hand side where I see the AWS icon. And I see my developer tools are being loaded. I see CodeCatalyst available in here. You can see I can perform various CodeCatalyst related actions in here. I can open an existing dev environment. I can create a new one. I can look at what commands are available to me. So now I'm going to create a new dev environment. Again, I'm going to go back to the repository. The project is still, the space is still Cheesecake Shop, and the project is Cheesecake. And I'm going to select type and program language repository and the main branch. Again, I'm going to give it an alias. Various configuration options. Let's go ahead and edit the compute. Edit timeout to 60 seconds because I would keep on going back to my VS Code frequently, so I don't want it to time out quickly. And I'll hit create. So in a few minutes, what happens is my repository is available in here, and a new window for my remote dev environment opens up in VS Code. I can look at the folder structure and open up the README file. Once the README file is available, I can see a bunch of helper commands that I can execute in the terminal, and that's what I'm going to go ahead and do so that I can make myself familiar with the repository. In the absence of a dev file, something like this would take customers hours, and now we were able to create a customized dev environment in a matter of minutes. Yep. So as you can see, I executed all the commands that were available on the README, and that's what we have in store for VS Code. Can we switch back to the slides, please? CodeCatalyst comes in 2 tiers, free tier and standard tier. If you are interested in using dev environments, free tier customers get up to 60 hours of compute usage for 2 cores a month per space. And if you would like to use standard tier, then you get 200 compute minutes for every month per space. On standard tier, you have more compute options, such as 4, 8, and 16 cores. You have more persistent storage options, such as 16, 32, and 64 gigs of storage. Timur, do you want to take over? Thanks, everyone.
Thanks, Raul. What's next? How do you get started with CodeCatalyst? Go to the website. It's codecatalyst.aws. You can create an account. Super easy to do. Then I would say go into CodeCatalyst, spin up a Cloud9-based environment, play with that, understand how it works, play with the dev file, get comfortable with that. If you're a JetBrains user, try out Gateway. It's a great experience. And of course, if you're a VS Code user, as Rahul said before, you'll need the IDE toolkit, which you can get in the AWS marketplace. In the Microsoft VS Code marketplace. And then get out there and start building something cool. So we look forward to that. And again, not to harp on this, but it's going to be a good talk, I think. DOP317 and DOP317 are both today in this afternoon. And lastly, I just want to say thank you all. And if you could fill out the sessions survey in the mobile app, that would be great.